The story of making a Ferrari 488 actually begins not from the factory floor, but in front of a computer screen. When a customer from anywhere in the world enters Ferrari's official portal and selects the color, interior, special features and customization of their dream car, that information instantly reaches Ferrari's central ERP system in Maranello, Italy. This ERP system is essentially the brain of the entire factory. It automatically analyzes exactly how much aluminum will be needed to build this specific car, how much high-strength steel is required, which grade of carbon fiber will be used, how much of which color is needed, and what the entire production timeline will look like. The system takes only a few seconds to make these decisions and immediately sends digital instructions to every department of the factory. Automated cranes and AGVs, automated guided vehicles in the warehouse, activate at that very moment and begin supplying the necessary raw materials to the production line. When the massive rolls of aluminum and high-strength steel arrive from the warehouse, they first enter an automatic uncoiling machine. This machine flattens the rolls and advances them forward at a specific speed. Then begins the work of laser cutting robots. These robots are so precise that the measurement of each cut stays within a gap thinner than a human hair. The CNC system tells the robot exactly where to cut, in what shape to cut, and how much to cut. The laser robot follows those instructions and cuts out one metallic piece after another, arranging each piece on a conveyor belt. Throughout this entire process, not a single human touches anything directly. Only one engineer sits in a control room monitoring everything on a screen. Laser cutting complete hoga, cut pieces travel on an automatic conveyor to the pressing area. Here, massive pressing machines capable of generating thousands of tons of pressure are waiting. A robotic arm picks up the metallic pieces and places them in the machine's die. And in an instant, under tremendous pressure, that piece receives its desired shape. The hood, door panels, fenders and roof sections of the Ferrari 488 all take shape this way. After pressing is done, another robotic arm picks up that section and places it at a 3D scanning station. There, a scanning robot equipped with lasers and cameras measures every curve and every angle of the part and compares it with the digital design. If any part deviates even 1 millimeter, the system immediately rejects it and sends it to the recycling line. Carbon fiber is an indispensable material in building the Ferrari 488. The car's roof, diffuser, spoiler, and some chassis parts are made of carbon fiber because this material is simultaneously incredibly strong and extremely lightweight. To make carbon fiber parts, a robotic arm first lays thin layers of pre-preg carbon fiber one after another on a special mold in a very precise manner. The direction and angle of each layer is determined by computer, because these angles directly affect the strength and flexibility of the final part. After the layers are arranged, the entire mold is vacuum bagged and then enters an autoclave machine. There, at a temperature of 180 degrees Celsius and a specific pressure, the carbon fiber hardens and transforms into an extraordinarily durable structure. Every parameter of the autoclave machine is controlled by computer, and the process is entirely automated. To join the metallic parts together, the most advanced welding robots are used in Ferrari's factory. Robotic arms made by KUKA and FANUC simultaneously perform MIG welding, TIG welding, and laser spot welding. When assembling the main chassis structure of the Ferrari 488, these robots can create hundreds of weld points per minute. And each joint is so perfect that it is almost impossible to see from outside. After welding is complete, an ultrasonic testing robot sends sound waves inside each weld point to check whether there are any cracks or weaknesses. If even one weak weld point exists, the system identifies it and issues instructions for correction. After the chassis is complete, it moves on rollers into the painting area, and one of the longest and most complex processes in car manufacturing begins. First, at an automatic washing station, the chassis is completely cleaned with a special alkaline solution. Then, in a phosphate coating chamber, a robotic spray system creates a thin phosphate layer over the entire chassis, which will protect against rust in the future. After this, the chassis is completely submerged in an electro-deposition tank. In this tank, an electrical process applies the first protective layer of paint onto the metal surface. A massive robotic crane performs the work of lowering and raising the chassis into the tank. After this process, the chassis enters a high-temperature oven where the paint layer dries and hardens. After coming out of the oven, a robotic sanding machine smooths the surface, and then a primer coating robot applies several layers of primer. After each coat, drying and sanding continue again. When it comes to applying the main color, Ferrari's special painting robots go to work. The heads of these robots carry special rotary atomizers that turn the paint into extremely fine particles and spread them evenly into every corner of the chassis. The thickness of paint is measured in micrometers, and infrared sensors ensure that paint of the same thickness is being applied everywhere. After painting, a clear coat robot applies a transparent protective layer that makes the car's color deep and brilliant. The temperature, humidity, and air circulation inside the painting booth are entirely computer controlled, because these environmental factors directly affect the quality of the paint. After painting, a high-resolution camera system scans the entire car surface to check for any small bubbles, uneven color, or dust particles. If any problem is found, the laser system marks that specific location and the robot applies paint there again. While the painting process is going on, in another part of the factory, the heart of the Ferrari 488, its 3.9-liter twin-turbo V8 engine is being built. Engine manufacturing begins with a block of aluminum alloy. A computer-controlled CNC machining center starts working on that solid aluminum block. Milling cutters, drill bits, and boring tools change automatically one after another, and the engine block cylinders, water jacket channels, oil galleries, and bolt holes begin to form. Every measurement must be accurate to micrometer precision, because if the inner diameter of a cylinder is even 1 micrometer more or less, the piston fitting will not be correct and the engine's efficiency will decrease. After coming out of the CNC machine, a coordinate measuring machine, CMM, verifies every measurement and compares everything with the digital design.
Forged chrome molybdenum steel is used for crankshaft manufacturing.
A robotic forging press heats the steel to nearly 1000 degrees Celsius and then applies tremendous pressure to give the crankshaft its initial shape. After forging, a CNC lathe machine grinds every bearing journal of the crankshaft extremely precisely to make it smooth. Pistons are made from a special silicon aluminum alloy, and the weight of each piston is measured to 1/1000th of a gram precision. The weight of all pistons in the same engine must be exactly equal, because even slight imbalance can create dangerous vibrations at high RPM. Valves, connecting rods, camshafts, turbocharger housings, everything is made through the same type of CNC process and robotic machinery. When engine assembly begins, the engine block is placed on a special jig and robotic arms start fitting the parts one by one. When installing the crankshaft, the robot tightens each main bearing cap bolt to the exact specified torque, and that torque value is digitally recorded. A special piston ring compressor robot is used when inserting the piston and connecting rod assembly into the cylinder. When installing the cylinder head, the position of the head gasket and the torque of the head bolts are extremely important, and the robot can do this job far more precisely than a human. After the camshaft, timing chain, turbocharger, intake manifold and exhaust manifold are all installed, the engine is taken to an engine test cell. There, an automatic diagnostic system tests the engine from cold start all the way to maximum 8000 revolutions per minute. Oil pressure, temperature, vibration levels, horsepower output and torque are all measured in real time and compared with specified values. If the engine does not pass this test, it is not installed in the car. When the painted chassis and the tested engine are ready, it's time for them to come together on the main assembly line. The chassis is placed on a moving platform that slowly moves through various assembly stations. At the first station, robotic arms attach firewall insulation to various parts of the chassis. Then a wiring harness robot installs the complete electrical cabling system in the chassis. After the harness is installed, an electrical test robot checks every circuit. The fuel tank, brake lines, clutch lines, hydraulic lines and cooling system piping are installed through automated systems. After each hydraulic and fuel line connection, a leak detection system confirms there are no leaks anywhere. At the suspension installation station, robotic arms very carefully place each component of the Ferrari 488's double wishbone suspension. Each bolt is tightened to the specified torque and digitally recorded. A laser alignment system checks the position of all four wheels and ensures that camber, caster, and toe angles are exactly at specified values. After the brake system is installed, an automatic brake bleeding system removes all air from the brake lines and fills them with brake fluid. Then a massive robotic crane lifts the complete engine and transmission assembly and carefully lowers it into the chassis. After the engine mounting bolts are tightened to specified torque, the robot connects the cooling hoses, fuel lines, and electrical connectors to the engine. At the interior assembly station, the dashboard unit is installed. This unit has already been completely assembled separately in another area. The steering column, pedal box, instrument cluster, air conditioning unit, and infotainment system are all connected together with the dashboard. A robotic arm lifts this complete unit and places it inside the car, and a vision system confirms it is seated in the correct position. Carpet, headliner, and door panels are installed by special installation robots. Special seat installation robots are used for seat installation, which hold the seat in the correct position and tighten the bolts. For installing glass, a robotic arm equipped with vacuum suction cups lifts the windshield and installs it with special polyurethane adhesive. A camera system confirms the windshield is seated in exactly the specified position and the gaps on all sides are equal. The rear glass and side windows are installed in the same way. When installing body panels, robotic arms carefully attach the doors, hood, and trunk lid, and a laser measurement system measures the gap of each panel. In the Ferrari 488, body panel gaps must be accurate to 1/10 of a millimeter. After all assembly is complete, the car enters the electrical diagnostics station. An automatic testing system connects with the car's central computer through the OBD port and tests each electrical system one by one. Headlights, fog lights, brake lights, turn signals, horn, power windows, central locking, airbag system, ABS, ESC, traction control, and infotainment system are all tested. Then on a roller test bench, the car's wheels are placed on rollers and the engine is started. Engine performance at various speeds, transmission shifting, and braking system are tested, and all data is stored on the central server. Then the car enters a water leak test tunnel where powerful water jets fall on the car from all directions. A sensor system installed inside immediately detects if any water enters. At the emission testing station, exhaust gases are examined and it is confirmed that the car is complying with all environmental regulations. In the final visual inspection, in a specially illuminated chamber, high-power cameras scan every surface of the car and an AI system analyzes whether there are any defects. After passing all these tests, the Ferrari 488 finally goes to the test track located next to the factory. This is where direct human involvement first becomes important at a critical stage. A skilled test driver takes the car to the track and at various speeds, at various angles, brakes, accelerates, and tests the steering response. Hundreds of sensors installed in the car send all information in real time, and engineers analyze that data on screens. After passing the track test, the car returns to the diagnostic center. Analyzing all sensor data confirms that the car has met Ferrari's specified highest standards. After passing all tests, the Ferrari 488 then goes to the final preparation stage. The car is completely cleaned, all protective films are removed, and a paint polishing robot makes the entire exterior surface as shiny as a mirror. Fuel is added, tire pressure is set to the specified value, and all of the car's software is updated to the latest version. The car is then wrapped in special protective film and covers and carefully placed in a climate-controlled transport container. When the Ferrari 488 reaches its owner, and at that special moment, the owner starts the engine for the first time, the roar that is heard is actually the combined voice of thousands of robots' tireless hard work, the extraordinary capability of artificial intelligence, and the indomitable dreams of Ferrari's engineers. This incredible journey from a lifeless iron plate to becoming one of the world's finest supercars proves that when technology and dreams unite, the creation of something extraordinary is only a matter of time.